Hello everyone. Today we shall discuss about the first chapter of organic chemistry, that is some basic principles and techniques, which is the first chapter of organic chemistry, which contains the introduction part, nomenclature, isomerism, reactive intermediates, and electron displacement effects. Means it contains the basic concepts of organic chemistry. So it is also called as general organic chemistry. Okay. So first we shall start with the introduction part. And what is the definition of organic chemistry? Organic chemistry is a branch of chemistry which deals with carbon and its compounds. Means which is the study of carbon and its compounds. Okay, why the carbon is so important? When you look at the periodic table, the carbon is present in the group 2 of the periodic table, and lithium, beryllium, boron, nitrogen, oxygen, fluorine are the means neighbor elements of the carbon. When you look at the properties of these neighboring elements, the lithium, beryllium and boron are present on the left hand side of carbon. Nitrogen, oxygen, fluorine are present on the right side of the carbon. The elements which are present on the left side of carbon, means the lithium, beryllium, boron, have a tendency to donate electrons. Means they can easily donate electrons. And the elements which are there on the right hand side of the carbon have a tendency, these nitrogen, oxygen, fluorine have a tendency to accept electrons. Okay, but the carbon is different from these elements. It can share electrons with the other atoms. So because of this unique property of this carbon, means it can easily share electrons with the other atoms. So it can make a easily bonds with the carbon and the other atoms. Okay, so this unique property is called as catenation. Because of this unique property, it can easily make a covalent bond with the other carbon atoms or the other elements. Okay, then organic compounds are present in the DNA, protein, RNA. These are the these all constitute the essential compounds of our body, means blood, muscles, and skin. And also, organic compounds are useful in the clothing, fuels, polymers, dyes, and medicines. But uh, we thought that the organic compounds cannot be synthesized in the laboratory. In the year 1807, in the year 1807, Berzelius has proposed what he has proposed. He has proposed that we can get the organic compounds. Only from the living organisms. Means we can get the organic compounds only from the living organisms. For this we need a force. We need a special or a strong force. That force is called as vital force. Okay, and also he has told that the meaning of this is we can get the organic compounds only from the living organisms. For that we need a vital force. Vital force means it's a strong force. And he also told that we cannot get the organic compounds, we cannot synthesize organic compounds in the labs. You cannot synthesize organic compounds in the laboratories. Okay, but in the year 1828, name of the scientist is Friedrich Euler, has synthesized this is the structure of urea. Okay, in the laboratory he has taken this ammonium acetate. He has taken the ammonium acetate. He has taken the ammonium acetate and he has heated the ammonium acetate so that he got urea. Okay, means he told that you can also synthesize this urea in the laboratory. He told that he has synthesized this urea in the laboratory by using ammonium acetate. He has heated the ammonium acetate, he got the urea. He proved that we can also synthesize organic compounds in lab. So means this is the first organic compound synthesized in the laboratory from ammonium acetate. The name of the scientist is Frederick Lorer. Okay, and the later in the year 1845 Kolbe synthesized acetic acid, and in the 1856 Berthelot synthesized methane in the laboratory. Okay, so this is about the basics, some simple introduction. Means here we shall discuss the some basic principles techniques discuss ಮಾಡತ್ತೀವಿ. ಇದೇನಿರ್ತದೆ ಇಂಟ್ರೊಡಕ್ಷನ್ ಪಾರ್ಟ್ ಅದ, ನಾಮೆನ್ಕ್ಲೇಚರ್, ಐಸೋಮೆರಿಸಮ್ ಅದ, ರಿಯಾಕ್ಟಿವ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ಸ್ ಅದ, ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಇಫೆಕ್ಟ್ ಅದ. ಸೊ ಇದೆಲ್ಲ ಏನದ, ದೀಸ್ ಆರ್ ದಿ ಬೇಸಿಕ್ಸ್ ಆಫ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ. ಅದಕ್ಕೆ ಏನಂತಾರೆ, ದಿಸ್ ಚಾಪ್ಟರ್ ಈಸ್ ಜನರಲಿ ಕಾಲ್ಡ್ ಆಸ್ ಜನರಲ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಅಂತ ಕರೀತಾರೆ. ಸೊ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಡೆಫಿನೇಷನ್ ಅಂದ್ರೆ ಇದು ಸ್ಟಡಿ ಆಫ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಮತ್ತು ಆರ್ಗ್ಯಾನಿಕ್ ಇದು ಸ್ಟಡಿ ಆಫ್ ಕಾರ್ಬನ್ ಮತ್ತು ಅದರ ಕಂಪೌಂಡ್ ಸ್ಟಡಿ ಮಾಡೋದು ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ. ಕಾರ್ಬನ್ ಯಾಕೆ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂದರೆ, ನೀವು ಪಿರಿಯಾಡಿಕ್ ಟೇಬಲ್ ನೋಡಿದರೆ ಏನಾಗ್ತದೆ, ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಕಾರ್ಬನ್ ಗ್ರೂಪ್ 2 ಒಳಗಡೆ ಏನದ, ಕಾರ್ಬನ್ ಅದ. ಕಾರ್ಬನ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಏನೇನದ, ಲಿಥಿಯಮ್, ಬೆರಿಲಿಯಮ್, ಬೋರಾನ್ ಅದ. ರೈಟ್ ಸೈಡ್ ನೈಟ್ರೋಜನ್, ಆಕ್ಸಿಜನ್, ಫ್ಲೋರಿನ್ ಅದ. ಲಿಥಿಯಮ್, ಬೆರಿಲಿಯಮ್, ಬೋರಾನ್ ಅವು ಏನು ಮಾಡ್ತಾವೆ, ಈಸಿಲಿ ಇಲೆಕ್ಟ್ರಾನ್ ಕೊಡ್ತಾವೆ. ಬಟ್ ನೈಟ್ರೋಜನ್, ಆಕ್ಸಿಜನ್, ಫ್ಲೋರಿನ್ ಅದ ಈಸಿಲಿ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ತಾವೆ ಇಲೆಕ್ಟ್ರಾನ್ಸ್. ಬಟ್ ಕಾರ್ಬನ್ ಏನದ, ಕಾರ್ಬನ್ ಈಸಿಲಿ ಶೇರ್ ಮಾಡ್ತದೆ ಇಲೆಕ್ಟ್ರಾನ್. ಓಕೆ, ಈಸಿಲಿ ಶೇರ್ ಮಾಡೋದ್ರಿಂದ ಏನಾಗ್ತದೆ, ಇದು ಈಸಿಲಿ ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಮಾಡ್ತದೆ ವಿತ್ ಕಾರ್ಬನ್ ಆರ್ ವಿತ್ ದಿ ಅದರ್ ಅಟಮ್ಸ್. ಸೊ ದಿಸ್ ಯುನಿಕ್ ಪ್ರಾಪರ್ಟಿ ಏನದಲ್ಲ, ಇಟ್ ಕ್ಯಾನ್ ಮೇಕ್ ಅ ಬಾಂಡ್ಸ್ ವಿತ್ ದಿ ಅದರ್ ಕಾರ್ಬನ್. ದಿಸ್ ಪ್ರಾಪರ್ಟಿ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಕೆಟನೇಷನ್. ಓಕೆ, ಮತ್ತು ಕಾರ್ಬನ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಎಲ್ಲೆಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಇರ್ತಾವೆ, ವಿ ನೋ ದ್ಯಾಟ್ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಒಳಗೆ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಇರ್ತಾವೆ. ಬ್ಲಡ್, ಕ್ಲಾತಿಂಗ್, ಫ್ಯೂಯಲ್ಸ್, ಪಾಲಿಮರ್ಸ್, ಮೆಡಿಸಿನ್ಸ್ ಎಲ್ಲ ಕಡೆ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಇರ್ತಾವೆ. ಬಟ್ ಅರ್ಲಿಯರ್ ನಾವೇನು ಥಿಂಕ್ ಮಾಡಿದ್ವಿ ಅಂದರೆ, ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ಬರ್ಜಿಲಿಯಸ್ ಏನು ಹೇಳಿದ್ದಲ್ಲ, ಅದರಿಂದ 1807 ಬರ್ಜಿಲಿಯಸ್ ಅನ್ನೋ ಸೈಂಟಿಸ್ಟ್ ಹಿ ಹ್ಯಾಸ್ ಟೋಲ್ಡ್ ದ್ಯಾಟ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ನಾವು ಲ್ಯಾಬ್ರೇಟರಿ ಸಿಂಥೆಸಿಸ್ ಮಾಡೋಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಯಾಕಂದ್ರೆ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಲಿವಿಂಗ್ ಆರ್ಗ್ಯಾನಿಸಮ್ಸ್ ಒಳಗಿರ್ತಾವೆ, ಅದರಿಂದ ಅಷ್ಟೇ ನಾವು ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ತೆಗಿಬೋದು. ಅದಕ್ಕೇನದ, ನಮಗೆ ಸ್ಪೆಷಲ್ ಫೋರ್ಸ್ ಬೇಕಾ, ದ್ಯಾಟ್ ಫೋರ್ಸ್ ಇಸ್ ಅ ವೈಟಲ್ ಫೋರ್ಸ್. ಆ ವೈಟಲ್ ಫೋರ್ಸ್ ಇದ್ದರೆ only we can synthesize organic compounds from the living organism. The carbon, what is the atomic number of carbon? Atomic number is 6. Electronic configuration is 1s2 2s2 2p2. Okay, this is K shell, this is L shell. So we shall directly consider the electrons are in the outermost orbital. So that this is 2s and 2p. There are 2 electrons in the 2s, 2 electrons in the 2p. This is in the ground state. In the excited state, one electron will be in the s and another electron goes to p, so that there is one electron in the s, say 2s, and 2p ಒಳಗಡೆ one electron in the, there are 3 electrons in the p orbitals. Okay, then ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, ಕನ್ಸಿಡರ್ ದ್ಯಾಟ್ ಎಸ್ ಆರ್ಬಿಟಲ್ ಹೆಂಗಿರ್ತದೆ, ಹಿಂಗೆ ಎಸ್ ಆರ್ಬಿಟಲ್, p orbital will be dumbbell shaped like this. Okay, there are one electron in the s orbital, one in the this p, another in the this p, another in the this p. Okay, when these orbitals mix together, when these orbitals mix together, so that we are going to get the other orbital, though that orbital is called a hybridized orbital. Okay, here you consider this 1s means this s orbital and these 3p orbitals combined together going to give the sp3, going to be the sp3 hybridized carbon. Means ಏನಾಗ್ತದ 1s orbital and 3p orbitals combined together going to give the 4 sp3 orbitals. These orbitals are called as hybridized orbitals. This carbon is called as sp3 hybridized carbon. Okay, then similarly second case, this is first case, second case, there are 3p orbitals. Here 1s and 2p orbitals are involving in the conjugation, in this hybridization. Means 1s ಮತ್ತು 2p orbitals are combining together going to give the hybridized orbitals. Okay, here you can see that 1s orbital ಅದ 2p orbitals ಅದಾವ, ಮೂರು ಏನಾಗತ್ತಾವ, ಮೂರು combined ಆಗಿ hybridized ಆಗಿ we are going to get the hybridized orbitals. 1p orbital is unhybridized. Okay, this is unhybridized as it is. Okay, this carbon is called as sp2 carbon. Okay, this carbon is called as sp2. Here you can see that 1s and 2p orbitals combined together to give the hybridized orbitals. This is one sp2 hybridized orbital, this is another sp2 hybridized, this is another sp2 hybridized. Totally there are 3 sp2 hybridized orbitals are there, and this carbon is called as sp2 hybridized carbon. Similarly, s orbital plus 1p, so here in this case only 1p orbital is involving in the conjugation. Means 1s and 1p are involved in the conjugation to give how many hybridized orbitals. Here we are combining 2 orbitals, so that here also we are going to get the 2 orbitals, 2 hybridized orbitals. Means how many number of unhybridized p orbitals are there? There are 2 unhybridized p orbitals are there. One is this, and there is this. Okay, here 1s orbital and the 1p orbital involved in the hybridization to give the 2 sp2 hybridized sp hybridized orbitals. Okay, so that this carbon is called sp hybridized carbon. And how many number of p orbitals are unhybridized? Here these 2 p orbitals are unhybridized, means these are not involved in the hybridization. Okay, then we shall consider the how we can make a bond. Okay, for the understanding purpose, the structure of this sp3 carbon is tetrahedral, and this sp2 carbon is trigonal planar, and this is sp2 carbon is linear. Okay, how it can make a bonds with other carbon. Okay, for understanding purpose I will write like this, and this is the same, and this is linear. Okay, I will write the structures here. This is one carbon atom. Okay, This is sp2 hybridized carbon. Here you can find the one unhybridized p orbitals. Here you can find the two unhybridized p orbitals. Similarly, this carbon, when this carbon is making a new bond with this carbon, this is also sp2 hybridized carbon. Here you can see that. Okay, and here we have one H, another H, another H. So one H. These are the hydrogens. These are the carbons. This is another hydrogen. This is a hydrogen. This is also hydrogen. Okay. See, this is a carbon. This is also another carbon. This carbon is this, and this carbon is this. Okay. This carbon is sp3 hybridized carbon. Here are the one sp3 orbital, second one, third one, and fourth one. So the total there are 4 sp3 orbitals are there. This carbon also having 4 sp3 hybridized carbon. So that this carbon is also sp3 hybridized. This carbon is also sp3 hybridized. Okay. And one of the sp3 hybridized orbital is overlapping with the another sp3 hybridized orbitals of this carbon, so that this overlap is axial overlap. So you know that axial overlap going to give the sigma bond, and sideways overlap going to form the pi bond. Correct. So here you can see that this sp3 of this carbon and sp3 of this orbital overlap axially, so that there is a formation of sigma bond. Here you can find the formation of sigma bond between this carbon and this carbon. And this is a hydrogen, and electronic configuration of hydrogen is 1s1. So this is s orbital of hydrogen. One s orbital of hydrogen is overlapping with this sp3 in the axial overlap, so that there is also formation of sigma bond. Here you can find the formation of sigma bond. Here also same, s orbital of hydrogen overlapping with the sp3 of this carbon, so formation of sigma bond. Here also same. Here also you can see that sp3 of this carbon overlapping with the 1s of this hydrogen going to form the sigma bond. Here also going to form the sigma bond. Here also going to form the sigma bond. Okay. So totally there are 7 sigma bonds are there. There is no pi bonds, and because there is no unhybridized p orbitals are there. Okay. So these carbons are sp3 hybridized carbon. What about the second case? We know that this is the same. This is the sp2 hybridized orbital, and here we have one unhybridized p orbital is there. Here also same, all are same. Here also we have one unhybridized p orbital which is not involved in the hybridization. This is carbon and this is carbon. Okay. See, the carbon sp2 hybridized orbital of this carbon is overlapping axially with the sp2 of this carbon, so that there is a formation of sigma bond. This is axial overlap, so there is a formation of sigma bond. This another sp2 is overlapping axially with the another 1s of hydrogen. Here also hydrogen 1s is overlapping with the sp2 of this carbon. Here also same. Here also you can find that 1s of this hydrogen overlapping with the sp2 of this carbon, and this is also same, 1s of this hydrogen overlapping axially with the sp2 of this one, so that there is a formation of here for this is the sigma bond. Here also this is sigma bond. Here also we have the sigma bond. Here also a sigma bond. Then what about this unhybridized p orbitals? These can overlap by sideways. Okay, this can overlap by sideways, so that there is a formation of pi bond. So that there is a formation of pi bond. Here you can see that this is sp2 hybridized, this is also sp2 hybridized. Okay, so the unhybridized p orbitals are overlap sideways, so that there is a formation of pi bond between this carbon and this carbon. This is structural representation. Okay, then the third case, we have two sp orbitals. For this carbon, this is one sp, this is one sp. For this carbon, this is one sp and this is one sp. There are two unhybridized orbitals are there. Okay, this is carbon and this is another carbon. This carbon and this carbon overlap axially. This sp orbital overlap with the another sp of this carbon, so that there is a formation of sigma bond. And here there is another sp orbital, here also another sp orbital. This is overlapping with the hydrogen, 1s of hydrogen. Here also overlapping of 1s hydrogen, so that there is formation of sigma bond with the other. So here for this carbon we have two p orbitals, these are unhybridized. Here also we have two unhybridized p orbitals. So this p orbital is overlapping with this p orbital by the sideways. You can see that here also the overlapping is by the sideways, so overlapping with the sideways, so that there is a formation of two pi bonds, because this overlap, this p orbital and this p unhybridized orbital overlapping form this one pi bond. This unhybridized p orbital overlapping with the another p unhybridized p orbital, so that there is a formation of another pi bond. Okay, this is one pi bond and this is another pi bond. This carbon is sp hybridized, this is also sp hybridized carbon. Okay, you can ಮತ್ತೊಮ್ಮೆ ಹೇಳ್ತೀನಿ ನೋಡ್ರಿ. Atomic number of carbon is 6, electronic configuration 1s2 2s2 2p2 ಅದ. K shell ಒಳಗಡೆ 1s2 ಹೋಗ್ತದ, L shell ಒಳಗಡೆ 2s2 2p6 ಇರ್ತದ. ಸೊ that this is the outermost orbital containing the 4 electrons. ಇಲ್ಲಿ ಏನದ 2 electron ಇಲ್ಲಿರ್ತದ, 2s ಒಳಗೆ ಇರ್ತದ, 2 electron 2p ಒಳಗಡೆ ಇರ್ತದೆ. ಓಕೆ, ಸೊ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಒಳಗಡೆ ಆಗ್ತದೆ 1 electron goes to the p orbital. ಅವಾಗ ಏನಾಗ್ತದೆ 1 electron s ಒಳಗಡೆ ಇರ್ತದೆ, 3 electron p ಒಳಗಡೆ ಇರ್ತದೆ. ಈ p ಒಳಗಡೆ ಒಂದು, ಈ p ಒಳಗೆ ಒಂದು, ಈ p ಒಳಗೆ ಒಂದು ಇರ್ತದೆ. ಓಕೆ, there are 3 cases. ಏನಾಗ್ತದೆ, ಅದು 1s ಅದ ಅಂದ್ರೆ ಒಂದೇ ಎಸ್ ಆರ್ಬಿಟಲ್ ಅದ. ಇಲ್ಲಿ ಅದ ಇದು p ಆರ್ಬಿಟಲ್ಸ್ ಎಷ್ಟು ಅದಾವ, 3 ಅದಾವ. 1 s ಆರ್ಬಿಟಲ್ ಮತ್ತು 3 p ಆರ್ಬಿಟಲ್ ಎಲ್ಲ 3 ಕಂಬೈನ್ ಆದರೆ ಏನಾಗ್ತದೆ, ಸೊ ದೇರ್ ಇಸ್ ಎ ಹೈಬ್ರಿಡೈಸ್ಡ್ ಆರ್ಬಿಟಲ್. ಅಂದರೆ ಹೈಬ್ರಿಡೈಸೇಷನ್, ದಿಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ಇನ್ ದಿ ಇನ್ಆರ್ಗಾನಿಕ್ ಪಾರ್ಟ್, ಅಲ್ಲಿ ಕಲಿತೀರಿ. ಇದು ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, 1 ಎಸ್ ಮತ್ತು 3 ಪಿ ಕೂಡಿದ್ರೆ ಏನಾಗ್ತದೆ, ಟೋಟಲ್ ಎಷ್ಟು ಕಂಬೈಂಡ್ ಆಗ್ಯಾವ, ಇಲ್ಲಿ ಟೋಟಲ್ 4 ಕಂಬೈಂಡ್ ಆಗ್ಯಾವ. ಸೊ ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಬರಬೇಕು, ಎಷ್ಟು ಆರ್ಬಿಟಲ್ಸ್ ಹೈಬ್ರಿಡೈಸ್ಡ್ ಆರ್ಬಿಟಲ್ ಆಗಬೇಕು, 4 ಆಗಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ 1 sp3 1 s and 3 p, ಸೊ ದ್ಯಾಟ್ ಇಟ್ ಈಸ್ sp3 ಹೈಬ್ರಿಡೈಸ್ಡ್ ಆರ್ಬಿಟಲ್ಸ್. ಎಷ್ಟು ಇರ್ತವೆ, 4 ಇರ್ತವೆ, ಯಾಕಂದ್ರೆ 4 ಕಂಬೈನ್ ಆಗಿಲ್ಲ. ಸೊ ದಟ್ ದ ನಂಬರ್ ಆಫ್ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ ಆರ್ಬಿಟಲ್ಸ್ ವಿಲ್ ಬಿ 4. ದಿಸ್ ಈಸ್ 1 2 3 and 4. ದಿಸ್ ಕಾರ್ಬನ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ sp3 hybridized carbon. ಓಕೆ, ದ ಸ್ಟ್ರಕ್ಚರ್ ಹೆಂಗಿರ್ತದೆ, ಟೆಟ್ರಾಹೈಡ್ರಲ್ ಅದ, ಮೇಲೆ ಒಂದು ಇರ್ತದೆ, ಈ ಕಡೆ 3. ಸೊ ದ್ಯಾಟ್ ಇಸ್ ದ ಸ್ಟ್ರಕ್ಚರ್ ಟೆಟ್ರಾಹೈಡ್ರಲ್ ಇರ್ತದೆ. ಓಕೆ, ಇದನ್ನು ವಿ ಆರ್ ಟೇಕಿಂಗ್ ಇಟ್ ಲೈಕ್ ದಿಸ್. This you know this is sp3, this is also sp3, this is also sp3, this is also sp3. Okay, ಮತ್ತೊಂದು sp3 ಜೊತೆ ಕಂಬೈನ್ ಆದರೆ ಏನಾಗ್ತದೆ, here you can see that this is the overlap of this sp3 of this carbon to sp3 of this carbon, so that there is a formation of sigma bond ಫಾರ್ಮ್ ಆಗ್ತದೆ. ಇಲ್ಲಿ ನೋಡ್ರಿ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಯಿತು. ಹೈಡ್ರೋಜನ್ ಇಲೆಕ್ಟ್ರಾನ್ ಕಾನ್ಫಿಗರೇಷನ್ 1s1. ಈ ಎಸ್ ಒಳಗಿಂದ ಇದು ಎಸ್ ಆರ್ಬಿಟಲ್ ಆಫ್ ದಿಸ್ ಹೈಡ್ರೋಜನ್ overlapping with the sp3 orbital of this carbon, so making the sigma bond. ಎಲ್ಲಾನು ಹಂಗೆ ಆಗಿದೆ. ಸೊ ಕಾರ್ಬನ್ ಸಿಗ್ಮಾ ಬಾಂಡ್, ಸಿಗ್ಮಾ ಬಾಂಡ್, ಸಿಗ್ಮಾ ಬಾಂಡ್, ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಸಿಗ್ಮಾ ಬಾಂಡ್, ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್ ಸಿಗ್ಮಾ ಬಾಂಡ್. ಸೊ ಇದು ಕಾರ್ಬನ್ sp3, ಇದು ಕಾರ್ಬನ್ sp3 ಹೈಬ್ರಿಡೈಸೇಷನ್. ಓಕೆ, ಸೆಕೆಂಡ್ ಕೇಸ್ 1s ಮತ್ತು 3p ಒಳಗಡೆ 1p ಈಸ್ ನಾಟ್ ಇನ್ವಾಲ್ವಿಂಗ್ ಇನ್ ದ ಹೈಬ್ರಿಡೈಸೇಷನ್. 1p ಹೈಬ್ರಿಡೈಸೇಷನ್ಗೆ ಇನ್ವಾಲ್ವ್ ಆಗೋದಿಲ್ಲ. 1s ಮತ್ತು 2p ಅಷ್ಟೇ ಇನ್ವಾಲ್ವ್ ಆಗ್ತವೆ. ಸೊ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಎಷ್ಟು ಇನ್ವಾಲ್ವ್ ಆದವು ಆರ್ಬಿಟಲ್ಸ್ 3 ಇನ್ವಾಲ್ವ್ ಆದವು. ಸೊ ಹೈಬ್ರಿಡೈಸ್ ಆರ್ಬಿಟಲ್ ಎಷ್ಟು ಬರಬೇಕು? 3 ಬರಬೇಕು. 1s and 2p, so that 1s and 2p, so that is sp2 hybridized carbon. ಟೋಟಲ್ ಎಷ್ಟು ಬರಬೇಕು? 3 sp2 ಹೈಬ್ರಿಡೈಸ್ಡ್ ಆರ್ಬಿಟಲ್ ಬರಬೇಕು. 1 p ಆರ್ಬಿಟಲ್ ಹಂಗೆ ಉಳಿದದ, ದಿಟ್ ಈಸ್ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಲ್. ಇದು ಹೈಬ್ರಿಡೈಸೇಷನ್ಗೆ ಇನ್ವಾಲ್ವ್ ಆಗಿಲ್ಲ. ಓಕೆ, ಇದೇ ಸೇಮ್ ಮತ್ತೊಂದು ಕಾರ್ಬನ್ ಅದ ಇಲ್ಲಿ. ಈ sp2, ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ sp2 ಕಾರ್ಬನ್, ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ sp2 ಕಾರ್ಬನ್. sp2 ಆರ್ಬಿಟಲ್ ಆಫ್ ದಿಸ್ ಕಾರ್ಬನ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಎಕ್ಸೇಲ್ ವಿತ್ ದಿ sp2 ಆಫ್ ದಿಸ್. ಓವರ್ಲ್ಯಾಪ್ ಆದರೆ ಏನಾಗ್ತದೆ? ಎಕ್ಸೇಲ್ ಓವರ್ಲ್ಯಾಪ್ ಇದ್ದಾಗ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ ನಿಮ್ಮದು. ಇಲ್ಲಿ 1s ಹೈಡ್ರೋಜನ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಎಕ್ಸೇಲಿ ವಿತ್ ದಿ sp2 ಆರ್ಬಿಟಲ್ ಆಫ್ ದಿಸ್ ಕಾರ್ಬನ್. Similarly, another hydrogen having a 1s electron, 1s that is in the 1s orbital. ಅದೇನಾಗ್ತದೆ? ಈ 2 sp2 ಇನ್ನು axial overlap ಆಗಿ there is a formation of sigma bond. Here also there is a formation of sigma bond. ಇದೇನು ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಲ್ ಇಲ್ಲಿ ಒಂದು ಇತ್ತಲ್ಲ, ಇದಕ್ಕೂ ಒಂದು ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಲ್ ಅದ. ಇದೆರಡು ಸೈಡ್ ವೇಸ್ ಓವರ್ಲ್ಯಾಪ್ ಆಯಿತು. ಸೈಡ್ ವೇಸ್ ಓವರ್ಲ್ಯಾಪ್ ಆದರೆ ಏನಾಗ್ತದೆ? ಪೈ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ. So that there is a formation of pi bond between this carbon and this carbon. So the carbon is called as sp2 carbon. This is also called as sp2 carbon. Okay, ಇಲ್ಲಿ ಎಷ್ಟು ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಲ್ ಅದಾವ? ಈ ಮಾಲಿಕ್ಯೂಲ್ ಒಳಗಡೆ there are 2 unhybridized p orbital. This carbon having one hybridized p orbital, this carbon having one hybridized p orbital, unhybridized p orbital. Okay, similarly third case 1s orbital and more p orbital ಒಳಗಡೆ these two are not involving in the hybridization. Only ಏನಾಗತ್ತದ? ಈ s orbital ಮತ್ತು p orbital are involving in the hybridization. ಎಷ್ಟು ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ ಫಾರ್ಮ್ ಆಗಬೇಕು? 2 ಇನ್ವಾಲ್ವ್ ಆಗತ್ತ. ಸೊ ದ್ಯಾಟ್ 2 ಫಾರ್ಮ್ ಆಗಬೇಕು. ಇದು ಯಾವುದು? ಇದು ಒಂದು ಮತ್ತೊಂದು ಇದು. ಓಕೆ, ಸೊ ದಿಸ್ ಕಾರ್ಬನ್ ಈಸ್ ಕಾಲ್ಡ್ sp hybridized carbon. The orbitals are called as sp2. This is one sp and the another sp. ಓಕೆ, ಎರಡು ಏನು p orbitals ಹಂಗೆ ಉಳಿದಾವ. these are called as, this is one unhybridized p orbital, this is another unhybridized p orbitals. Okay, similarly this is also same sp hybridized carbon, this is also sp hybridized carbon. This sp hybridized orbital overlap axially with the another sp hybridized orbital. So there is a formation of sigma bond in this carbon. ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ 1s ಎಲೆಕ್ಟ್ರಾನ್ ಏನಿದೆ ಹೈಡ್ರೋಜನ್ ಒಳಗೆ ಅದೇನಾಗ್ತದೆ? ಓವರ್ಲ್ಯಾಪಿಂಗ್ ವಿತ್ ದಿ sp ಆಫ್ ದಿಸ್ ಕಾರ್ಬನ್. ಸೊ ದೇರ್ ಇಸ್ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಸಿಗ್ಮಾ ಬಾಂಡ್. ಹಿಯರ್ ಆಲ್ಸೋ ದಿಸ್ sp ಏನಿರ್ತದೆ ಹೈಡ್ರೋಜನ್ ಒಳಗಡೆ ಅದು ಈ ಥರ ಓವರ್ಲ್ಯಾಪ್ ಆಗೋದ್ರಿಂದ ದೇರ್ ಇಸ್ ದ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್. ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ sp, ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ sp. ಓಕೆ, ದೆನ್ shall note what is the s character in this molecule. How many unhybridized p orbitals are there? For this carbon there are 2 unhybridized p orbitals. For this carbon we have 2 unhybridized p orbitals. So totally for this molecule we have 4 unhybridized p orbitals ಇರ್ತವೆ. ಓಕೆ, s ಕ್ಯಾರೆಕ್ಟರ್ ಎಷ್ಟು ಇರ್ತದೆ? sp3 ಒಳಗಡೆ s ಕ್ಯಾರೆಕ್ಟರ್ ಎಷ್ಟು ಇರ್ತದೆ ನೋಡಿರಿ. 4 ಅದಾವ, 4 ಇನ್ವಾಲ್ವ್ ಆಗ್ಯಾವ. s ಕ್ಯಾರೆಕ್ಟರ್ ಎಷ್ಟು ಇತ್ತು? ಎಷ್ಟು ಕ್ಯಾರೆಕ್ಟರ್ ಎಷ್ಟು ಬಂತು? 25%. ಇದರಲ್ಲಿ sp3ಯಲ್ಲಿ ಎಷ್ಟು ಪರ್ಸೆಂಟ್ ಅದ? ಎಸ್ ಕ್ಯಾರೆಕ್ಟರ್ 25% ಅದ. ಓಕೆ, ಯಾಕಂದ್ರೆ 4ಅಲ್ಲಿ ಒಂದೇ ಎಸ್ ಅದ, ಒಂದೇ ಎಸ್ ಇನ್ವಾಲ್ವ್ ಆಗಿದೆ. ಇಲ್ಲಿ ಏನಾಗಿದೆ? 3 ಅದಾವ sp2 ಒಳಗಡೆ, 3 ಇನ್ವಾಲ್ವ್ ಆಗ್ಯಾವ. ಸೊ 3 ಇನ್ವಾಲ್ವ್ ಆಗ್ಯಾವ, ಎಷ್ಟು ಬರ್ತದದು? ಎಸ್ ಕ್ಯಾರೆಕ್ಟರ್ 33.3%. ಯಾಕಂದ್ರೆ ಒಂದು ಎಸ್ ಟೋಟಲ್ 3 ಒಳಗಡೆ ಒಂದೇ ಎಸ್ ಅದ. ಓಕೆ, ಇಲ್ಲಿ ನೋಡಿರಿ, ಇನ್ನು sp ಒಳಗಡೆ ಒಂದು ಎಸ್ ಅದ, ಒಂದು ಪಿ ಅದ. ಸೊ ದಟ್ ಎಷ್ಟಿರ್ತದೆ ಇಲ್ಲಿ? ಎಸ್ ಕ್ಯಾರೆಕ್ಟರ್ 50%. ಎಸ್ ಕ್ಯಾರೆಕ್ಟರ್ ಗೊತ್ತಾಯ್ತಾ? sp3 ಒಳಗಡೆ ಏನಾಗ್ತದೆ? 25% ಆಫ್ ಎಸ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇರ್ತದೆ. sp2 ಒಳಗಡೆ 33.3% ಆಫ್ ಎಸ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇರ್ತದೆ. sp ಒಳಗಡೆ 50% ಎಸ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇರ್ತದೆ. ಓಕೆ, ದೆನ್ ಬಾಂಡ್ ಲೆಂತ್ ಎಲ್ಲಿ ಹೆಚ್ಚಿರ್ತದೆ? ಬಾಂಡ್ ಲೆಂತ್ ಓಕೆ ಓಕೆ, ಈ 3 ಪ್ರಾಪರ್ಟಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಬಾಂಡ್ ಲೆಂತ್, ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಾನೆಗೆಟಿವಿಟಿ. ಬಾಂಡ್ ಲೆಂತ್ ಹೆಚ್ಚೆಲ್ಲಿರ್ತದೆ? ಯು ಕ್ಯಾನ್ ಸಿ ದ್ಯಾಟ್ there is a highest bond length between this carbon and this carbon. Okay, this carbon and this carbon are loosely binded than these two carbons. So that sp3 in carbon irtadalla, sp3 irtadalla, this having highest bond length, then comes to sp2, then sp carbon. Okay, ಅಂದರೆ ಇವು ಟೈಟ್ಲಿ ಬೈಂಡೆಡ್ ಇರ್ತಾವೆ, ಅಂದ್ರೆ ಭಾಳ ಟೈಟ್ ಬೈಂಡೆಡ್ ಆಗಿ, ಬಿಕಾಸ್ ದೆರ್ ಆರ್ 2 pi electrons. ದೇರ್ ಇಸ್ 1 electron, ಸೊ ದಟ್ ಇದಕ್ಕಿಂತ ಇದು ಲೂಸ್ ಬೈಂಡ್ ಆಗಿರ್ತದೆ. ದೇರ್ ಇಸ್ ನೋ pi electron, ಓನ್ಲಿ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಅದ, ಸೊ ದಟ್ ಇದಕ್ಕೆ ಇವು ಎರಡಕ್ಕಿಂತ ಇದು ಲೂಸ್ಲಿ ಬೈಂಡೆಡ್ ಇರ್ತದೆ. ಸೊ ದ ಬಾಂಡ್ ಲೆಂತ್ ಎಲ್ಲಿ ಹೆಚ್ಚಿರ್ತದೆ, ಬಾಂಡ್ ಲೆಂತ್ ಇದಕ್ಕೆ ಹೆಚ್ಚಿರ್ತದೆ, ಆಮೇಲೆ ಇದಕ್ಕೆ ಕಡಿಮೆ ಇರ್ತದೆ. ಓಕೆ, ಸ್ಟ್ರೆಂತ್ ಎಲ್ಲಿ ಹೆಚ್ಚಿರ್ತದೆ, ವೇರ್ ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ ದಿ ಸ್ಟ್ರೆಂತ್, ಹೈಯೆಸ್ಟ್ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್. ಇಫ್ ದ ಬಾಂಡ್ ಲೆಂತ್ ಈಸ್ ಹೈಯರ್, ಸ್ಟ್ರೆಂತ್ ಈಸ್ ಲೆಸ್. Where we can find the highest bond length, for sp3 we can find the highest bond length, so the strength will be, it is opposite. For sp3 the strength is lower than the sp2, and sp2 carbon is bond strength is lower than sp, because these two are tightly bonded. Bond length is less but strength is more. Here the strength is higher than this one, length is lower than this one. Okay, and what about electronegativity? Electronegativity also same as the bond strength. For sp carbons having highest electronegativity than sp2 than sp3. Okay, this is the characters, this is the properties of the carbons for different hybridizations. Hope you understood this. Okay, now we shall discuss about structural representations of organic compounds and how we can represent this compound structurally. There are 4 different types of representations. By 4 different methods we can represent the organic compounds. First one is condensed formula, and the second one is complete formula, and the third one is bond line for representation, and the fourth one is 3-dimensional representation. Okay, condensed formula means there is no need to show the bonds. Okay, you can say, shall write the CH2 CH3, this is condensed formula. Okay, CH3 CH2 CH3 is a condensed formula. How you can write this condensed formula, complete formula? There is, here we don't write the where it is bonded, means whether the hydrogen is bonded with the carbon or this hydrogen is bonded with the carbon. Here we will not show the bonds, but in the complete formula we show the bonds. See, there are same structure. See here, same, this is also propane, this is also propane. This carbon is attached, made a bond with this carbon, this is attached to this carbon is attached to 3 hydrogens, this is attached to 2 hydrogens, this is attached to 3 hydrogens. This is the structural condensed formula representation of this propane. This is complete formula representation of this propane. Then how we can write the bond line structure? There just show the lines. Okay, here we cannot write the carbon and hydrogen. The meaning of this is there is a carbon, meaning of this is there is a carbon, meaning of this is there is a carbon. So there are 3 carbons and valency of carbon is 4. So this carbon is attached, have made up 3 bonds. Meaning of this is there is a carbon, there are 3 hydrogen attached to this carbon and 1 is attached to this carbon. Here this carbon is attached to this carbon and this carbon, there is a 2 hydrogens. Meaning of this is this carbon is attached by 1 bond with this carbon and there is a 3 hydrogens are there. This is the bond line representation of the propane. And this 3-dimensional representation means here will show the where means whether the atoms which are attached to one carbon are above the plane, below the plane or in the plane. Okay, see, one carbon, write like this. CH3. So this is also propane. The meaning of this is this carbon is in the plane the hydrogens, the bonds, these bonds show that these two hydrogens are in the plane. This dashed wedge shows that this methyl group is below the plane. This is away from them, it's below the plane. This wedge, the solid wedge, meaning of the solid wedge is the methyl group is above the plane. The carbon is in the plane, hydrogen and these two hydrogens are in the plane. It shows the bonds, and this wedged dashed wedge shows that this methyl group is below the plane, and this solid wedge shows that this methyl group is above the plane. This is called structural representation of the propane. Okay, next example is pentane. This is condensed formula. There we have not shown the bonds. Okay, just we have shown the molecular formula, just like means CH3 CH2 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 CH3. This is condensed formula. Then we shall write the complete formula. How many carbons are there? 5 carbons are there. 3 4 5 carbons are there. For this carbon there are 3 hydrogens are attached. For this carbon there are 2 hydrogens. For this carbon there are 2 hydrogens. For this also there are 2 hydrogens. For this there are 3 hydrogens. This is complete formula, complete structural formula of this pentane. Then how we can write the bond line structure? Here we cannot show the hydrogens and carbons. How many carbons are there? 5. You have to write this in the zigzag formula. This is one carbon, this is another carbon, third carbon, fourth carbon and fifth carbon. Okay, so here 1 2 3 4 5 carbons are there. 1 carbon, 2 3 4 and 5. This is the bond length representation. There is no need to show the hydrogens or the carbons. This is called the bond length representation. Then what about three-dimensional structure? Here you can show the above the plane and below the plane. These bonds shows that these two, the groups which are attached to this carbon are in the plane, and these two, one is below the plane, one is above the plane. Here you can take that this CH2CH3 is above the plane, and this CH2CH3 is below the plane, and 2 hydrogens are in the plane. 1 2 3 4 5 carbons are there, same molecule, and this methyl group is below the plane, but this ethyl group is below the plane, this ethyl group is above the plane. This is the structural representation of this pentane. Okay. Okay, now we shall discuss about the classification of organic compounds. How we can classify the organic compounds? For that, we note on the different types of organic compounds first. Okay, these are some of the examples of organic compounds. Now classify these organic compounds. Now the first criteria is, look at these compounds. This is how we can classify. You can classify based on the this one, whether it is cyclic or not. See that this is not cyclic, this is not cyclic, this is cyclic, this is also cyclic, this is not cyclic, this is also cyclic, cyclic, cyclics. Okay, so that the first thing in the classification is can classify as a cyclic or open chain. Open chain. Here you can classify this is cyclic or also called as closed chain or also called as ring compounds. Okay, we are classifying based on the whether it is a ring open or it is a closed. This is also open, correct, right here. This is also open, CH3 and this is also open structure, CH2 double bond CH3. This is also open having triple bond. Okay, these are comes to this cyclic or open chain structure classification, and this is also ring, 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 and this is also ring. Okay, now how we can divide these elements, how we can classify these elements? Here you can see that this is a single bond and here you can find the double bond. What is the difference? Difference is this carbon having single bond, but this carbon having double bond, this carbon having triple bond. How we can classify this? We can classify this as saturated and unsaturated. Okay, saturated means if the compound having carbon single bond, if the compound having carbon single bond, it is called as saturation. And unsaturated compounds are if compound having any double bond or triple bonds, these are called as unsaturated. Once again I repeat, saturated compounds are called as if compound having should have the carbon single bond, and unsaturated means if in the compound if there is a presence of double bond or triple bonds are called as unsaturated compounds. Here also you can see that there is a double bond, here also there is a triple bond, so that these comes under unsaturated. So there is no double bond in this compound, so that this is called as a saturated compound. Okay, then these are the closed structure or cyclic structure. How can you classify this? See here there are 6 carbon atoms are there, here also there are 6 carbon atoms are there, here there are 4 atoms, 1 oxygen is there, here also there are 6 atoms, in the ring there are 6 atoms, in the ring there are 7, in the ring there are 4 and 1 oxygen is there. Okay, and how we can classify these? We can classify these on in 1 and 2 and 3. Just look at these 3. All the atoms are carbons in the ring, but here the oxygen is there in the place of carbon. So based on this we can classify these cyclic structures as homocyclic or heterocyclic. Okay, homocyclic. And what are homocyclic? Homocyclic means in the ring all the atoms are carbon only. Here you can see that all the atoms in the ring are carbon. In this also all the atoms are the carbons only, but here there is no carbon in the ring, we have one oxygen in the place of carbon, so that this comes under heterocyclic atom. Here also all the atoms are carbons in the ring, so that this is comes under heterocyclic. This is also heterocyclic. Okay, then this is also heterocyclic. Okay, then how we can differentiate homocyclic? Here you can see that there is no double bond. Here you can find the double bond. You can differentiate homocyclic compounds as alicyclic and aromatic. What is the meaning of aromatic? Aromatic means the compound should be planar. There are some criteria or rules to be called as aromatic. First one is planar, that should be planar, and they should be conjugated, means all the atoms should have a vacant, means unhybridized p orbital. Atoms should have unhybridized p orbital, and it should follow the 4n plus 2 pi electron system. Means this is a Huckel rule. This should follow the 4n plus 2 pi electron system. These are the rules to be called as aromatic. Here you can see that is it aromatic? No, because it is plain. There is no conjugation. It is not planar. Right? There is no conjugation, so that this comes under homocyclic. But this compound is planar, and it satisfies the aromatic rules, so that this comes under the aromatic compound, and this is also aromatic, NH2, and this is also the aromatic compound. Okay, then there is no classification in the alicyclic. These are the alicyclic compounds, all are single bonds. These are the examples of alicyclic compounds. In the aromatic, again we can differentiate these two based on the whether these are benzenoid or non-benzenoid. Benzenoid means the compounds which having the benzene ring. These two having the benzene ring, so that these two comes under benzenoid. This is not having the benzene ring, so that this comes under non-benzenoid aromatic compounds. Then what about heterocyclic? Here you can see that both are heterocyclic. Means there is in the place of carbon we have these heteroatoms. Okay, I will tell you what are heteroatoms. Heteroatoms are usually nitrogen, oxygen, sulfur. These are the important heterocyclic compounds. Okay, these in the place of carbon, if you add this if you find this nitrogen, oxygen or sulfur, these are called as heterocyclic compounds. These are called as heteroatoms, and when we have the heteroatoms in the ring, these are called as heterocyclic compound. We can again classify these based on aliphatic heterocyclic compounds and aromatic heterocyclic compounds. Okay, already we know that what is the meaning of aromatic. Aromatic, if the compound should be called as aromatic, then it should be planar, and there should be a conjugation of electrons, and it should follow the 4n plus 2 pi electrons. Out of these two, there is no double bonds, so that this is called aliphatic heterocyclic compound. This comes under aromatic heterocyclic compound. Okay, this is the classification of the organic compounds. Hope you understood this concept. Now we shall discuss about functional group. What is functional group? Functional group means this word indicates a group is it's an atom or group of atoms which determines the function of that compound. Okay, if this group is present in that compound and this group indicates the function of that whole compound, that is called as functional group. So definition, it is an atom or group of atom which determines the properties of organic compounds. So the meaning of the functional group is this atom or group of atom which determines its properties or the function of that organic compound. Okay, now shall discuss which are the functional groups and which determines its property. Alcohol is OH is the functional group of alcohol, and CHO is the functional group of CHO, it is functional group of aldehyde, and CO, okay, C double bond O is the functional group of ketone. COOH is the functional group of carboxylic acid. C double bond O, OH is the functional group of carboxylic acids. Next, NH2 is the functional group of amine. So NH2. Okay. Then ethers. O having the two bonds means here you can have the alkyl groups both the sides. This is the ether functional group. Halogens, we indicate the halogens as X. X, meaning of X maybe the fluorine, chlorine, bromine and iodines are the halogens. Fluorine, chlorine, bromine and iodines are the halogens. We indicate these halogens as X. Then next, amides. CONH2 is the functional group of amide. Can indicate the structural representation. This is the structural representation of amide, CONH2. And phenol. Phenol functional group is when OH group is directly attached to the benzene ring. This is called as phenol. When OH group is attached to alkanes or alkyl groups, then that is alcohol. But OH group is, if the OH group is directly attached to phenyl ring, then or the benzene ring, then that is phenol. Phenol functional group. Okay. Then COCl is acid chloride. C double bond O, Cl is acid chloride. And then CN, can write it like this. This is nitrile. This is nitrile functional group. Okay, hope you have understood this. Functional group, meaning of functional group. Functional group andre ಏನು, this atom or group of atom which indicates the function of that compound. It is an atom or group of atom which determines the properties of organic compounds. These are called as functional group. These are the functional group. OH is the functional group of alcohol. CHO is the functional group of aldehyde. CO is for ketone. COOH is for carboxylic acid. NH2 is for amine. O is for ethers. X is for halogens. CONH2 is for amides. If the OH group is attached to benzene ring, that is called as phenol functional group or phenol. Acid chloride, COCl is acid chloride. CN is nitrile. Okay, now we understand the classification of organic compounds. Now we shall understand how we can classify the carbon atoms in the molecule. Here you can see that this is CH3. This is CH3. This carbon is attached to hydrogen, and this carbon is having two hydrogens, and this is attached to this another carbon. This carbon is attached to three methyl groups. Okay, how we can classify these carbons in the molecule, in the single molecule? What we call this carbon, what we should call to this carbon atom, and which is this carbon, which is this carbon. We shall understand that how we can classify these carbon atoms. See, you can classify these carbon atoms as primary, secondary, tertiary, and quaternary. If the carbon atom is attached to hydrogens, means we know that the valency of carbon is 4. Okay, so that it can make a 4 bonds with other atoms, either the hydrogens or the carbons. See here, the carbon is having valency 4, so that it can make 4 covalent bonds with the other atoms. So this carbon is attached to 4 hydrogens. This is also called as primary carbon. Okay, and also if the carbon is attached to another carbon, out of 4, it is out of 4 bonds, it can make only one bond with the other carbon atoms, and it is having 3 hydrogens, so that this carbon is called as primary carbon atom. This carbon is called as primary carbon atom. Okay, then what about secondary? Secondary means if the carbon atom is attached to 2 carbon atoms, means it attached to 2 another carbon atoms and 2 hydrogens, so this is called as secondary carbon atom. Okay, this carbon is called as secondary carbon atom. Out of 4, there are 2 hydrogens and 2 carbon atoms. Okay, then what about tertiary? This is tertiary carbon atom. Here you can see that this carbon is attached or made a bond with 3 carbon atoms, so that this carbon is called as tertiary carbon atom. Okay, then what about quaternary? If the carbon is attached to 4 carbon atoms, if the carbon is attached to 4 carbon, this middle carbon is attached to 4 carbon atoms, then this carbon is called as quaternary carbon atom. So like this, you can classify these compounds. Here you can see that there is a molecule. What about this? This here you can see that this carbon is having 3 hydrogens and 1 bond is with this carbon, so that this is called, see here, this carbon is attached to 1 carbon and 3 hydrogens, so this is also same, so that this is primary carbon atom. And what about this? This carbon is attached to 1 carbon, 2 carbon, 3 carbon and only 1 hydrogen. See here, 1 carbon, 2 carbon, 3 carbon, only 1 hydrogen, so that this carbon is tertiary carbon atom. What about this? This is same as the methyl, this is CH3 group, so that this carbon is attached to only 1 carbon and having 3 hydrogens, so that this is also primary carbon atom. And what about this? Out of 4 bonds, it had made 2 bonds with carbon, 1 bond with this carbon, another bond with this carbon, and there are 2 hydrogens here. This is secondary carbon atom. Okay, then what about this? This is 1, 2, 3 and 4, all the 4 bonds with the carbon atom. Here this carbon is same as this one, so that this is quaternary carbon atom. Then this is primary, this is also primary, and this is also primary carbon atoms. Okay, if the carbon is attached to 4, the methyl group is exceptional. First, this is the only compound, only molecule having 4 hydrogens. This name of this is methane, and this is having all the 4 bonds with the hydrogen, so that this is also considered under primary. And if the carbon is made out of 4 hydrogens, if you replace 1 with the CH3, then that is primary carbon atom. If only 2 hydrogens and 2 carbons are there, then that is secondary. 3, if the carbon is attached to 3 carbon atoms, that is tertiary. And if carbon is attached to all the 4 carbon atoms, then that is classified as quaternary carbon atom. Then if the hydrogens, okay, this is about the carbon. Then what about hydrogens? These hydrogens which are attached to primary carbon atoms are called as primary hydrogen atoms. Primary hydrogen atoms. Why these are called primary hydrogen atoms? Because these hydrogens are attached to primary carbon atoms. And what about this? This hydrogen is called as, okay, this hydrogen is attached to tertiary carbon atom, because this carbon is attached to 3 carbon atoms, so that this is tertiary. This hydrogen is attached to this tertiary carbon atom, so that this hydrogen is called as tertiary hydrogen atom. What about this? There are 2 hydrogens which are attached to the secondary carbon atom, so that these 2 hydrogens are called as secondary hydrogen atoms. Okay, and what about this? There is no hydrogens because the quaternary carbon is attached to 4 carbon atoms, so there is no hydrogen attached to this quaternary carbon, so there is no quaternary hydrogen atoms. This hydrogen is also called as, these hydrogens are also called as primary hydrogen atoms. Okay, we have understood that how we can classify these carbon atoms with respect to the carbon atoms which are attached to this carbon atom. Okay, now we shall understand how we can classify the carbon atoms with respect to the functional group which is attached to or which is present in the molecule. Here you can see that this is a COH functional group. COH means carboxylic acid. This is OH means alcohol. This is CHO, aldehyde functional group. With respect to this, how we can classify this carbon and this carbon? The carbon which is attached to the directly attached to the function group, this carbon is called as alpha carbon. The carbon which is attached to the directly attached to the function group, this carbon is called as alpha carbon, and the next is called as beta carbon. And these 2 hydrogens which are attached to alpha carbon atoms are called as alpha hydrogens, and these 3 hydrogens which are attached to beta carbon atom are called as beta hydrogens. Here you can see that the OH is a functional group of alcohol, and this carbon is directly attached to this functional group, so that this carbon is called as alpha carbon atom. Hydrogens are called as alpha hydrogens. This carbon is beta carbon. Hydrogens are beta hydrogens. And the next is, this is gamma hydrogen. OH carbon is attached directly to the OH functional group, alpha carbon atom, beta carbon atom, gamma carbon atom, and the hydrogens are called as gamma hydrogens. And this carbon, the CH2 is alpha, this is beta carbon atom and beta hydrogens.